Hi, I'm Dennis from Dennis Harlock Studio Furniture. I'm here today working with CNC Labs to talk about the Mark II and the router spindle itself. So some do's and don'ts and what you should be doing to your spindle and your router bits to ensure that they're performing to their maximum potential. Okay, so one of the first things that we're going to talk about is your router spindle. Now, one of the first things that you really need to understand is that when you do not have a router bit in the spindle, you should not tighten down the collet. It's really important because the collets themselves are manufactured to collapse a certain amount. And what you can do is you can over tighten it without a bit in there, and you can crack the collet without knowing. And if you have a cracked collet, it will not perform to the way it should. So what we're gonna do is we're gonna take out the collet and the locking nut. Okay? So you can see the collet with the Makita router that CNC Labs carry. You can see the shape of the collet, and if you notice on the bottom part here, there is a small taper. That's what causes the collet to collapse around your bit to hold it in. Now there is a matching taper on the inside of the spindle. Okay? Now, it's very important that when we are mounting new tools and new collets that we ensure that we're clean on the inside. We want this as clean as possible. We do not want any real lubricants in the collet. Now, the other thing is, in here you can see that you may get a little bit of residue inside the bottom there. So what you want to do, and I like to use a brass brush and just give it a little scrub and to try to clear away some of that material. Now, the only thing I recommend putting in here, and I'm sure everybody will have it in their household, is one of the great lubricants is just plain paraffin wax. So if you have some waxed paper, what you want to do is just put it on the inside and just rub it. It will clean that a little bit, and what it will do is it will put a very, very thin film of paraffin wax on it. Not enough to build. So what happens is, when I do this, it acts as a slight lubricant because everybody knows when we tighten that collet and the nut on metal tends to wear. Now, in ideal circumstances, the metal on the collet is a harder material than the spindle. So what happens, if we don't have something on there, we're gonna get metal on metal wear, and what's gonna wear is the spindle. Now, with the collet, it's important that your collet matches your exact router. Your collet, so here's a 1/4" collet for the Makita. Here is a 1/4" collet for a Delta. So here is a different collet for a 1/2" router. Now I'm going to switch over to a larger spindle just so you can see it a little bit better. This is a spindle that is off of my shaper where I can actually put a router spindle in it. Now the collets for this particular spindle, you can see the shape and you can see that there's a taper in here. Okay. Now there will be a matching taper inside of the spindle. Okay. And when the locking nut is tightened down, now I will go to the larger collets. One thing about all the manufacturers of all these router spindles is they all have their different designs, okay? Try that again. So all the manufacturers of the different spindles will have different collet shapes, okay? And you can see that here. So in an industrial setting, collets are standardized, and they come with what's referred to as an ER number. And so these are ER collets that will fit into this spindle. Okay, and you can see that here. Now what I want to show you is, you see the number of slots that are cut in here. Now those slots are alternating. This one's cutting from the top down, this one's cutting from the bottom up. That's to allow that spring steel to collapse around your tool. The problem with this, when they manufacture these, you end up with square corners on the bottom. Now, wherever you have a square corner, you have a chance for metal fatigue and cracking. So what happens is, if you were to take a spindle without a bit in it and tighten it down, you're overstressing this so that you will get microscopic cracks in here. And as soon as that happens, you need a new collet. Generally, as a rule, collets should be changed about every 500 hours. So from a standpoint, collets are relatively cheap. One thing that you should try to do is also, when you buy a collet, try to buy a locking nut as well, because these also wear, okay? Because they sit in. Now on this larger version, the collet actually snaps in, okay? So when this goes into the spindle, the way these work, because of that taper that's on the collet, when this gets tightened down, the collet actually comes down, okay? And as it comes down into that cone shape, it tightens up. So if we don't have a bit in here and we over tighten, what we're doing is we're over collapsing that spindle, and we can cause cracking in those slots. Now, you don't need much pressure when you're putting a bit in. So, as you can see here, the tool is loose. Now, you can see here how that is freely sliding. I'm just going to turn it a third of a turn, and that's locked in. Most people, what they will do is over tighten this. You can over tighten it. So what happens with that collet is, if you over tighten, you actually start twisting this. So as this gets twisted, you may be getting contact with the router bit at the top on this side and at the bottom on this side. So you want to make sure that you don't over tighten. And usually the standard for that would be 3 to 4 Newton meters, whatever that relates to. Okay, off the top of my head, I can't remember what this is. Now, when you're tightening, your machine will come with a set of wrenches. These wrenches are designed with this length for the right amount of torque. No hammers, no mallets, no pipes on the end of them, because they are designed specifically for the amount of torque and tightness of the collet. The other thing, a lot of people like to use the button on the side to lock it down. The problem with doing that is either the pin or the spindle have to have a softer metal, because in case something breaks. Also, the pin itself, and what you want to look for if you are using the pin or when you're buying a router to start with, is whether or not it has 2 holes in it. If it's only got 1 hole, I would tend to not use that type of router. The problem being is if this is running, there's 2 types of balance. Balance at rest and dynamic balance, which is balance in motion. Opposite sides have to be balanced. So if I have only 1 hole, this side of the spindle is lighter than this side. So as it starts to run, centrifugal force takes over and it causes run out on the spindle. So I tend not to use this, and you also want to look to make sure that you have both holes. If it's only got 1, if it's got somewhere where you can see it's taken metal out to balance it, that's okay. But I don't like to use that because it means I can probably end up getting more leverage when I tighten this down. Okay, so let's talk a little bit. We're going to talk more about collets, but just the position of the tool in the spindle. So if you notice, and again, I'm using larger bits here than what you would normally have. If you notice right here, the run out of the gullet for the bit, that's there because of manufacturing. These are, most carbide tools are cut and ground with diamond cutters. So this is a side effect of the grinding process, but it doesn't mean it's part of your overall cutting length. One thing that I see a lot of people doing is they'll put the bit in so far that the bottom part of that gullet is inside the collet. This can cause a couple of issues. If it's up into here, what you're doing is you're compacting fine dust up into the collet. Now, if we get enough pressure in there, we can actually split the collet and we can split the locking nut or the spindle. So you always, if you have a situation where your bit's going in, we want to pull it out slightly before we tighten it down, so we're not getting all those chips up into the collet. Now you can see that we will get some fine dust in there because the slots on the bottom of the collet, okay? Which we're trying to avoid worst case scenarios, so by having that gullet outside the collet, we will have a very good chance of not damaging the collet and the locking nut or the spindle. Now, at CNC Labs, we have 1/4-inch collets for the Makita router and 1/8-inch collets. So, depending on the tool that you're using, you may want to use an 1/8-inch tool or you may want to use a 1/4-inch tool. So, what's important is that we actually have the correct collet for the shank diameter of the tool. What I would suggest you do is buy the 1/8-inch collet if you're using a lot of 1/8-inch tools. You can get an adapter that can go into the 1/4 inch collet to take up the difference between a 1/4 inch and an 1/8 inch shank diameter. I would suggest that you use these as 1 or 2 time only. Now you have to remember, you are purchasing a router spindle for $200–300 or even cheaper to mount into your Mark II. The problem is, if we have this collet adapter that's under $10, to manufacture this, there's going to be manufacturing tolerances on it. And the cheaper it is, generally, the less tolerance there is. So our collets also have to get manufactured with a tolerance. We have a tolerance in the spindle. We have a tolerance in the locking nut. So what we are doing by using this 1/8 inch adapter is compounding out a tolerance for all the components. So if we eliminate one and go to an 1/8 inch collet, our bit is going to run more concentric as opposed to eccentric, because we can't fully guarantee that everything is going to collapse equally around the center of the tool. Okay, what we're going to do now is we're going to show you how to properly install a bit into the spindle. So if you look over here, we've got all the components that you need to install the bit into the spindle. We've got the spindle itself. We've got the appropriate size collet for the size tool that we're using, the locking nut, and the 2 wrenches for the compression of the collet to hold the bit in. So in this case, what we're going to do is we are going to put the collet in. We are just slightly turning this on and then mounting the bit. Now, what we want to make sure is that we don't have this continuation of the gullet inside the locking nut. And what we're going to do is we're just going to mount it. Now there's just a little bit of friction there now, and I want to leave it at that. Now if you notice, the bit is bottoming out on the spindle. You do not ever want to have the bit bottoming out on the spindle. A lot of people, what they will do is they will take their router, turn it upside down, and then tighten it. Now we talked about the collet and those expansion slots, how when we tighten the locking nut, the collet comes down and compresses around the shank of the tool. If the tool is already bottomed out, what actually happens when we tighten it is the bit gets drawn down. When it's drawn down, it collapses evenly around the collet. If it's bottoming out, it's rubbing against the shank of the tool, it's wearing out the inside of the collet, and also it's not correctly compressing all the way around the shank of the tool. So if you have a situation where your bit is bottoming out, you always want to take that tool, pull it out a 1/16 or an 1/8 of an inch. Now I said I never use the button, but in this case I'm just going to put it in, just get a little bit of finger pressure to hold it in. Then I will go and tighten the collet. Now when you tighten the collet, that's it. That's all you need. Any more than that, and what you're going to do is you're going to twist that collet and it's not going to hold tightly onto the shank of the tool. One of the important considerations of the tool that you're using is what material you're cutting And also, we also want to make sure that we're using the correct length bit. Now, as you can see, our bit is fairly long. The longer the bit, think of this bit as a lever. So if we have a long bit and we're cutting, the bit is going to move as it's cutting. And you'd be surprised under slow motion camera how much these actually move, but don't fly apart. Using a bit that is too long can cause some problems with your collets. One of the things that happens with this bit being so long, it acts as a lever. Where the bottom of the bit meets the bottom of the collet, it acts as a fulcrum, okay, a lever. So what happens when this bit is moving and cutting, we're putting lots of pressure on the inside bottom of the collet. And we tend to get wear on this edge of the collet. We get wear on the inside edge of this collet. Now when you look at your collet, you have a very small amount of taper here. If we wear on the inside, essentially what we're doing is we're reducing the amount of contact friction that we have holding the tool in. So what happens is if we use a tool that's too long, we get wear on the inside of your collet. And it could actually end up being eccentric wear. So what we're doing is we're increasing the amount of run out that's on your bit. So depending on what you are doing, you can see that I've got two different bits here. I would tend to use the shorter bit for shallow cuts, a longer bit for thicker material, okay? Or most people will try to buy universal bits. I tend to use the bit that's best suited for the job. So if you are using longer bits more often in your spindle, it probably means that you need to replace your collets more frequently. And collets are relatively cheap depending on how much sanding you want to do, because it's all about surface quality. Nobody likes to sand. So especially when I'm building furniture, you know, I don't want to spend all my time sanding. Okay? I try to eliminate as much machine issues as possible so that my sanding is reduced. You never want to sand to correct problems. Okay, we'll talk a little bit about installing braised carbide bits. The bits that I showed you before are solid carbide, okay, which if you ever want to go and see how this is made, look up a YouTube video on sintering, because these are actually made out of powdered metals. And when you buy bits, the big term now is micro grade and things like that. It's based on the size of the particles that are manufactured. Now, when we're installing braised bits, here's an example of a braised bit, which is made out of high-speed steel with carbide braised onto the surface. Now, when you manufacture these bits, you notice we've got a larger cutting diameter than a shank diameter. What happens is, at the very bottom here, you'll notice that there's a little radius. Again, that radius is there to relieve stress. We talked about the collets having a square bottom and getting stress cracks. If I was to use this bit and it had a sharp corner, I would probably not buy that bit, only because that is a place where the tool can fracture. So whenever we have a radius, we relieve that stress that's going to be created when we're in the cutting operation. So when I mount this tool, I want to make sure when I put it in, it doesn't bottom out on the bottom of the spindle. But my actual locking nut and collet is on that small radius on here. So what happens when I go to tighten this, it's only being tightened on the radius, and it could be in crooked, so we're gonna have lots of run out on that spindle. If that's the case, pull the bit out so that it's past the radius. Okay, and then we can tighten it up. And then again, we want to lock it. It's tight, okay? And just because we have a small cutting edge and we're still cutting deep, don't have the bit sticking out too far. Again, the farther it is out from that face of that collet, the longer the lever, the more wear that you're going to get in the collet. Now, along with the bits, the other thing that you want to make sure is that when you're mounting your spindle into the bracket, check to see if you've got a little lip here at the bottom or a small radius here, depending on the type of router you have. Because if you have that, you want to make sure your spindle is up to make sure that you're not on this radius and only making contact here as opposed to this whole face. Just to recap what we learned today, we want to make sure that our spindle is clean. We want to make sure our collets are clean. We want to make sure our collets are not damaged. And we want to make sure that our locking nut is cleaned as well. The other items that we talked about was bit length, using the appropriate length bit, not to have the flute go up into the collet, bit length, and we also don't want to over tighten the bit in the spindle. We also talked about replacing the collets when they're worn, why you should not use adapters. Adapter use is okay periodically, but if we can get a 1/8 inch collet, that's even better, and we will be way more satisfied with that as opposed to an adapter. So in the next video, we are going to talk about the different types of tooling. Braised carbide versus carbide, profile tools versus straight bits, and that video should be coming in the next month or so. Well, I hope you enjoyed today's video, and I hope you learned something that you didn't know. If you liked the video, please hit the subscribe button. And before we go, just a useful tip. We can use wax paper in the shop for more than just cleaning this. I always have a roll of wax paper in the shop. We can actually use the wax paper to rub on machine table surfaces to help lubricate them, and so your pieces go through planers and table saws easier. Also, they're great for under clamping, when you're clamping up panels and glue, that you clean up your mess. So hope you enjoy your day. See you next time.